Hello everyone, welcome back to IB360. Today we'll be solving Math AASL Paper 1 of Time Zone 1, and this is for me 2023 attempt. So let's start with the first question. So we have a point P which has the coordinates minus 3, 2 and point Q which has the coordinate 15, minus 8. And M is the midpoint of PQ. So first we have to find the coordinates of this midpoint. Let's say this is these are the 2 points P and Q. P, let's say, has a point minus 3, 2. Q, let's say, has a point 15, minus 8, right? M is the midpoint here. So coordinate of M would be x1 plus x2 by 2, y1 plus y2 by 2. We can assume P as x1, y1 and Q as x2, y2. If I plug in the values, minus 3 plus 15 by 2 and 2 minus 8 by 2. So this one would be like 6 and this one will be minus 3. So 6, minus 3 is the coordinate of point M. Now B. We have to find now line L is perpendicular to PQ and it passes through M. So we have to find the gradient of L. So first let's try to find the slope or gradient of PQ. Slope of PQ would be, can use the formula y2 minus y1 by x2 minus x1. So Q is x2 y2 and P is x1 y1. So minus 8 minus 2 divided by 15 minus of minus 3, which gives you minus 10 by 18, which is minus 5 by 9. This is the slope of PQ. Now we know if you have two perpendicular lines, so we know that product of the slope is minus 1. So slope of L times slope of PQ, product of the slopes will be equal to minus 1. So slope of L would be minus 1 divided by the slope of PQ. So minus 1 divided by minus 5 by 9, which is 9 over 5. This is the slope of L. Now in part C, we have to write down the equation of L. So equation of L will be y minus y3 equals m times x minus x3. Right. So x3, y3 is the coordinates of M. And slope of L can be denoted by this M. So y coordinate of point M is minus 3. So y minus of minus 3 is plus 3. M is 9 over 5 and x coordinate is 6, so x minus 6. Now I can simplify this. I can multiply the 5 on the other side. So it's 5y plus 15 and it's 9x minus 54. So if we finally get 5y equals 9x minus 69. This is the equation of line L. And with this, we are done with question 1. Let's move on to question 2. Now moving on to the next problem. So we have a function which is defined by fx equals 7x plus 7 divided by 2x minus 4. This is now defined for x equals 2. So we have to find the 0 of fx. So fx is 7x plus 7 divided by 2x minus 4. So yeah, 0 of fx means like the root of fx. This should be equated to 0. This will be equal to 0 when 7x plus 7, this becomes 0. So which is x equal to 7x equals to minus 7, which gives x equals minus 7 by 7, which is x equals minus 1. So x equals minus 1 is the root of this function. Now let's start with the next part. So for the graph y equals fx, you have to write the equation of vertical asymptote and the horizontal asymptote. For the vertical asymptote, we actually have to make the denominator equal to 0, right? So the denominator is 2x minus 4, so 2x minus 4 equals 0. So 2x would be equal to 4, x would be equal to 2. So x equals 2 is the vertical asymptote. Basically, the vertical asymptote appears when the denominator is 0. So yeah. And the second part is the horizontal asymptote. So horizontal asymptotes will appear at the end points of the graph. So when to find the horizontal asymptote, you basically have to put limit x tends to infinity. So yeah, so y equals limit x tends to infinity, and our function is 7x plus 7 divided by 2x minus 4. Now to solve this limit, what we'll do is we'll divide both the numerator and denominator with x. So 7 by 7x and 2 minus 4 by x. So anything divided by infinity, like say 5 divided by infinity, will always give you a 0. So yeah, we can make these two 0, and our horizontal asymptote will be y equals 7 over 2. So these are the answers to part B. For part C, we have to find the inverse function fx. Okay. So to find the inverse, what we have to do is we have to swap x and y. So basically our equation is y equals fx equals 7x plus 7 divided by 2x minus 4. So this is our original equation. Right. So to find the inverse, what we will do is we will swap the x and y. So if we swap them, so we'll get x equals 7y plus 7 divided by 2y minus 4. Now we have to write the equation like, as a subject of x. So 2xy minus 4x equals 7y plus 7. I'm transferring the denominator to the left side. So yeah, I'll bring the 7y to the left and 4x to the right. 2xy minus 7y equals 4x plus 7. We can take a y common. There's 2x minus 1 gives you 4x plus 7. 2x minus 7, sorry. 2x minus 7 will give you 4x plus 7. So y would be 4x plus 7 divided by 2x minus 7. So this is your inverse function fx. And here the only condition is x cannot be equal to 7 over 2. And that's all of the answer to question 2. Now if we move on to question 3, we have a question on probability. Pretty nice question. So yeah, on a Monday at an amusement park, a sample of 40 visitors was randomly selected as they were leaving the park. They were asked how many times that day they had been on a ride called the Dragon. Information is summarized. You have the table. So on the left column, you have the number of times they have taken the ride, and the frequency, like how many people. So for example, here 13 people have taken the ride twice, 3 people have taken the ride 4 times, and so on. So first we have to find the probability that a randomly selected visitor will ride the Dragon. So how to find part A1? A1 would be like, let's first find the total number of visitors. Total number of visitors in our sample space is 40, which is given here. And we have to find total how many visitors actually took the ride. So visitors who rode the Dragon. So basically, these visitors rode the Dragon at least once. Okay, so it's basically like how will I find it? So either you can add these up, or you can do 40 minus 6. So whichever is easy to understand. So basically, 34 visitors at least rode the Dragon once, right? So probability of visitor riding the Dragon. This is total number of visitors who rode the Dragon divided by total number of visitors, which is 17 over 20. This is the answer to A1. Now A2, you have to find expected number of times a visitor will ride the Dragon. So basically, we'll find total how many times the visitors of these 40 visitors rode the Dragon, right? And then divide it with 40, you'll get the expected number of times. So yeah, total number of times the 40 visitors the Dragon. So yeah, so 0 people, 6 people didn't ride it. So yeah, 16 people once, and then 13 people twice, 2 people thrice, and 4 people, and 3 people 4 times. Okay, so if I simplify this, is 0 plus 16 plus 26 plus 6 plus 4. No, 6 plus 12, sorry. 16, 6 are 22, 22 plus 26 is 48, 48 plus 12 is 60. So total number of times these 40 visitors rode the Dragon is 60. So expected number of times a visitor will ride the Dragon. This will be total number of times they have, they have rode the Dragon divided by like the total number of visitors, so which is 1.5. So we can say that every visitor coming in this amusement park will ride the Dragon 1.5 times on an average. So yeah, so moving on to part C, we have to find the minimum number of times the Dragon must run to satisfy this demand. Yeah. So basically, we'll assume that each person rides the Dragon 1.5 times. So total number of rides would be 1.5 times 100, 1000, because like here 1000 visitors have attended the amusement park, so total number of ride, yeah, it will be 1500. Now see, each time this Dragon can carry maximum of 10 people. So total number of times the Dragon must run, this is 1500 divided by 10, which is 150 times. And yeah, this will be the answer to part B. So with this, we are done with question 3. Now let's move on to question 4. Question 4 is a nice trigonometry question. So first we have to prove that cos 2x is equal to sin x. So if I start with the left, okay, so we have to prove cos 2x equals sin x can be written in this form, sorry. So this is equal to sin x. So cos 2x can be written as cos squared x minus sin squared x. Now cos squared x can be written as 1 minus sin squared x. I'll just write here the formula is used. Square x, and cos square x can be written as 1 minus sin square x. Okay, so 1 minus 2 sin square x equals sin x. So if I take sin x here, minus 2 sin square x minus sin x plus 1 equals 0, multiply both sides with negative 1, we'll get 2 sin square x plus sin x minus 1 equals 0. So we see that this expression is same as this expression, therefore we have proved it. Right. Now we need to solve this equation cos 2x equals sin x for the domain minus pi to pi. So yeah, so cos 2x equals sin x. This equation can be written as this thing, 2 sin square x plus sin x minus 1 equals 0. We just proved it in part A. Now to solve this equation, we'll take sin x as t. So this equation becomes 2t squared plus t minus 1 equals 0. Now I'll try to find the roots of this equation. How can we do that? Basically, we can factorize this equation. So how to factorize it? So basically, you have to break t into two parts. Is that the product of the parts gives you minus 2 and sum gives you plus 1. So we can write it as 2t minus t minus 1. Okay. So take 2t common, it will be t plus 1. Take negative 1 common, it will be t plus 1 again. Again, take t plus 1 common, it will be 2t minus 1. So yeah, we have two solutions now. T plus 1 equals 0 and 2t minus 1 equals 0. So t equals minus 1 and here t equals half. So sin x equals minus 1 and sin x equals half. You have to solve for x in the domain minus pi to pi. So how to do that? Basically, we can draw the sin x curve and easily solve easily solve this trigonometric equation. So this is sin pi. Okay, 0 to pi. Yeah, this is minus pi, and this is 0. Okay, so sin x equals minus 1. So we'll draw the line y equals minus 1. So y equals minus 1 line will probably be here. So yeah, this is the line y equals minus 1. So y equals minus 1 will only touch the curve at one point. Okay, so yeah, and this value for which y equals minus 1 is satisfied, this will be minus pi by 2. So sin x equals minus 1 will only be valid when x equals minus pi by 2. Done. Now x equals half. So I'll draw a line which is like y equals half. So line will run somewhere here. There's a line for y equals half. Okay. So there are two solutions for y equals half in our domain. The first one, sin x equals half occurs at pi by 6. Okay. So yeah, this value is pi by 6. And this value here would be, this distance would be pi by 6. So this value here will be pi minus pi by 6. Right. This will be pi minus pi by 6, which is 5 pi by 6. Right. So there are two solutions to this. X is equal to pi by 6 and x is equal to 5 pi by 6. So therefore, finally, there are three solutions to this trigonometric equation, which is minus pi by 2, pi by 6, and 5 pi by 6. So that's the answer to this question. Now let's move on to question 5. 5, we have to find the range of possible values of k such that this equation has at least one real solution. So we'll start by rearranging the equation. So this looks like a quadratic type equation, so we can just take e to the power x as t. We can use this substitution to make it t squared plus 3t plus ln k, right? So for this quadratic equation to have at least one real solution, what happens is the discriminant has to be greater than or equal to 0. If it's equal to 0, you have one real solution. If it's greater than 0, you have two real solutions. Right? So yeah, so therefore discriminant has to be greater than equal to 0. At least one real solution. Okay, the discriminant is b square minus 4ac. So here b is 3. Wait, I guess I made a sign mistake here. It will be negative. Negative here. B is minus 3 whole square. A is 1 and C is ln k. So 9 minus 4 ln k has to be greater than equal to 0. So minus 4 ln k greater than equal to minus 9. So divide both sides with minus 4. We'll get ln k will be less than equal to 9 by 4. So as we are multiplying both sides with a negative sign, what happens is we have to flip the inequality. So ln k is less than or equal to 9 by 4, right? So yeah, we have to find the value of k. So k would be equal to, ln k would be equal to 9 by 4 when k equals e to the power of 9 by 4. So that's the max value of k. Okay. And for ln, like the function log base e, what happens is the value of k has to be greater than 0. It cannot be equal to or less than 0. So this will be the range of k. And this is the answer to this question. This is the range of values of k possible. Now moving on to question 6, you have a function defined by this by fx equals sine qx, right? So the following diagram is giving us the graph, right? X intercepts are 0 to m and 4m. So first we have to find the expression of m in terms of q, right? You see from the curve we see that 4m is the period of this wave. Okay, so yeah, period is equal to 4m from curve, right? And from formula we know that period of sine a, sine qx would be 2 pi by q, right? This is from formula. So these two have to be equal, so you can equate them. 4m should be equal to 2 pi over q. Add a page here. Yeah. So here m would be equal to pi by 2q. This is the answer to part A. Now moving on to part B. So function d is defined by gx equals 3 sine 2q x by 3. So we have to sketch the graph g. Right. So as you have multiplied it with 3, your amplitude or the new amplitude would be 3, right? Initially it was 1. As you have 3 in front of sine, there will be a vertical shift of 3 units, right? So amplitude will become 3 now. And what happens to the period? So you have multiplied it with 2 by 3. So the horizontal shift will be again 3 by 2 times. Okay, the 2 by 3 for horizontal, we take it as 3 by 2. So period will be 3 by 2 times 4m, because 4m was the initial period, right? So we'll be stretching it 3 by 2 times. So this will be 6m. The period of the curve will be 6m. So yeah. So how will the curve look like? I'll just point out some important. So here is the first time it will cross. Here will be the second time. So 1.5n. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 6, right? So mhm. So and the third block or here basically will be our 1 point. Yeah, here will be our 3, right? And yeah, 3. Then 4.5 is first, second, third. This block you'll have minus 3. This is minus 3. So yeah, the curve should look somewhat like this. And then we will connect it. So yeah, this should be your approximate curve G. Okay, so yeah, now we'll move on to question 7. So in question 7, we have a function h, which is defined by hx equals 2x e to the power of x plus 3. So we have the following diagram that shows a part of the graph f. Local minima is at point A. We have to find the value of the y-intercept. Okay, so I'll add a page here. A. So the y-intercept occurs. Oh, wait. Yeah. So y-intercept occurs when x is equal to 0, right? Because at the y-axis, x is 0, right? Any point on the y-axis will have x as 0. So we have to find h of 0. H of 0 will be your y-intercept. So h of 0, right? How much will be h of 0? So h of x is 2x e to the power of x plus 3. H of 0 will be 2 to the power of 0 e to the power of 0 plus 3, which is equal to 3. So y-intercept is, yeah, y-intercept would be y equals 3. That's the answer to part A. Now moving on to part B, we have to find h dash x. Okay, so hx is 2x e to the power of x plus 3, right? And this is here. So h dash x, we have to apply product rule for 2x e to the power of x. So first I'll differentiate x, keep e to the power of x constant. Then I'll keep x as constant and differentiate e to the power of x. Differentiation of e to the power x is e to the power of x again. And differentiation of 3 is 0 because it's a constant. So h dash x is 2 e to the power of x plus 2x e to the power of x. This is the answer to part B. Now we would move to part C. For part C, we have to find the coordinates of A. Now A is a local minima, right? And at the local minima, what happens is your h dash x is 0, right? So A is a local minima. So at A, our h dash x would be equal to 0. So I'll equate h dash x to 0 and try to find the value of x. So yeah, h dash x equals 0, which is 2 e to the power of x plus 2x e to the power of x equals 0. I'll take e to the power x as common, so 2 plus 2x equals 0, right? So e to the power x cannot be equal to 0. It will be equal to 0 when x is minus infinity. We're not working on that case here. So 2 plus 2x equals 0, which gives us 2x equals minus 2, which gives us x equals minus 1. Okay. So the x coordinate of a is minus 1. Now we have to find the y coordinate. Y coordinate of a is like h of minus 1. That is 2 times minus 1 e to the power of minus 1 plus 3, which gives you 3 minus 2 by e. So need a more ph here. So yeah, the coordinates of a would be minus 1 comma 3 minus will be 2 by e. Yeah, this is the answer to part C. Okay, now moving on to part D, we have to find the double h double dash x. Okay, yeah. So h dash x, which we already found out as 2 e to the power of x plus 2x e to the power of x. So h double dash x would be how much? 2 e to the power of x. The differentiation of e to the power x is same. 2x e to the power of x, again the product rule. First I'll differentiate x, keeping e to the power x constant. Then I'll keep x constant and differentiate e to the power of x, which will again give me e to the power of x. This 4 e to the power x plus 2x e to the power of x. If I take e to the power of x common, we'll get 2x plus 4, right? So we have to prove this. 2x plus 4 e to the power of x, it looks like the same. So, okay, hence we have proved it, or hence proved. Now to the next part, we have to find the value of x for which h is concave up. So we have to find the sign scheme of h double dash x. So h double dash x will be equal to 0 for which values of x? So 2 x plus 4 times e to the power of x is 0, which is valid when 2x plus 4 will be equal to 0, which is valid when x equals minus 2. Right, so I'll draw the sign scheme of f dash x. Oh yeah, sorry, sign scheme of f double dash x. Yeah, so this is x equals minus 2. So h double dash x is this. So now what happens is I'll put a value of x in this equation which is greater than minus 2. Let's say I put x equals 0, right? So e to the power of 0, 2 times 0 plus 4. What happens? This is the equal to 4, right? Which is a positive number. So this entire interval from minus 2 to infinity, your f double dash x is positive. But if I put a value less than minus 2, let's say minus 4, right? So how much do you get? E to the power of minus 4, 2 times minus 4 plus 4, right? So this will be minus 4 e to the power of minus 4. This is a negative number. So basically, we can generalize that any value less than minus 2 h double dash x will be negative. So now function is concave up when yeah, this is not f, this is actually h double dash x. When h double dash x is greater than 0, and it occurs when x is greater than minus 2. So the x is greater than minus 2 will be your answer, right? So let's now move on to question 8. Okay, now in question 8, we have the arithmetic sequence u1, u2, u3. So it's an AP series, right? So first, sum of first n terms of the sequence is given by this general equation n square plus 4n. So we have to first find the first sum of the first 5 terms. So first five terms will be given by s5. So if I replace n with 5 in this equation, I'll get the sum of the first 5 terms. So yeah, so this is 25 plus 20, which gives us 45, right? This is sum of the first 5 terms s5. So they have given us that s6 is equal to 60, right? We have to find u6. So s6 is basically s5 plus u6, right? If I add the next term to the sum of the first 5 terms, I'll get the sum of the 6 terms, right? This is 60 equals 45 plus u6. So from here, u6 will be equal to 60 minus 45. So u6 is equal to 15. This is answer to A part 2. Now part B1. Yeah. Part B is we have to find u1. Right? How will I find u1? So basically, s of 1 is u1, right? Sum of the first one term. So what is s1? S1 is just u1. You are just adding the only one term here. So s1 is how much? So yeah, 1 square plus 4 times 1, which is 5. Therefore, u1 will be equal to s1, which is equal to 5. So this is the answer to part B. Now part C, we have to find an expression of un in terms of n. So for part C, I know that the first term of this AP series is 5. I have to find the common difference of the AP series. So let's just try to find u2. Or basically we can find No, we have to find S2 only. So S2 will be how much? 2 square plus 4 times 2, right? Which is 4 plus 8, which is 12. Therefore, S2 is U1 plus U2. So U2 would be 12 minus 5, which is 7. Okay. Now common difference D would be U2 minus U1. So if I did like subtract like two consecutive terms of an AP series, I'll get the common difference. So 7 minus 5, which is giving me 2. So I have the D here. So like yeah, U1 will be U1 plus n minus 1 times D. So U1 is 5, n minus 1, and D is 2. If I simplify it a little bit, we'll get 3 plus 2n. So this is the answer to part C, 3 plus 2n. Now moving on to part D. Now we have to consider a geometric series Vn where V2 is U1 and V4 is U6. Right? So we have to find the common ratio, possible values of the common ratio R. We'll add a page here. Yeah. So let's say the GP series looks like this: AR square, AR cubed, AR to the power of 4, AR to the power of 5, and so on. Okay. So basically this says that V2 is U1, right? So V2 is equal to AR square is equal to U1. U1 is equal to 5, right? Yeah. So basically, we know that AR square is 5. Now, it also says that the yeah, V4 is U6. U6 is 15, right? So, and V4 is AR to the power of 4 is equal to 15. Yeah. So, if I take divide these two, so AR to the power of 4 by AR square, this will be equal to 15 over 5. So, if I simplify, R square is becoming 3. So, R would be equal to plus minus root 3. So, these are the possible values of R. Now, moving on to the last part, that is E. So, in E, what they are saying is that V99 is less than 0. So, we have to find V5. Now, one observation from the first part, AR square is 5, right? So R square, even if R is negative root 3, R square would be positive, right? So as AR square is a positive number, which this means that A is always positive, okay? So A, I mean, will rule out the possibility that A is negative. Same from here, like R to the power 4 is positive, so the sign of this thing will depend upon A. So as 15 is positive, A would be positive. V2 and V4, we know A is positive. Okay, now they are saying that V of 99 is less than 0, right? So V of 99 will be AR to the power of 99, right? AR to the power of 99 is less than 0 only if R is less than 0, right? So therefore, the value of R would be minus root 3. This is the value of R in our GP series, right? Now we have to find A. How will I find A? So basically, you can use V2. So AR is minus 3, so AR square is 5. We can write A times minus root 3 whole square is 5. So A is equal to 5 over 3. Now I need to find, we need to find here V of 5, right? So V of 5 would be A R to the power of 5. That is V of 5. So A is 5 by 3. R is minus root 3 whole to the power of 5. So 5 by 3 times minus 3 times 3 times root 3. So upon simplification, we'll get minus 15 root 3, which is the answer to part E of question 8, right? And now I'll move on to question 9. Question 9 is a kinematics question. So the velocity is given to us, the equation of the velocity time equation. And we have like a number of parts to it. So slowly let's start. So first we have to, this is the curve. And first we have to find the displacement of the object from the origin at t equals 1. So basically displacement, we can find displacement if I integrate velocity with respect to time. So this will be done from 0 to 1. So oh yeah, so the equation of Vt was minus t cube plus 7 by 2 t square minus 2t plus 6. Minus 2t plus 6dt. Yeah. Upon integrating, I get minus t to the power 4 by 4 plus 7t cubed by 6 minus 2t square by 2, which is t square plus 6t. The lower limit is 0, upper limit is 1. So s would be equal to minus 1 by 4 plus 7 by 6 minus 1 plus 6 minus 0, because if you put 0 instead of t, entire thing will become 0. So if I simplify this, I'll get minus 3 by 12 plus 14 by 12 plus 5, which is basically 11 by 12 plus 5. So upon simplification, it's 11 plus 60 by 12. So S is 71 over 12 meters. This is the first part. This is the displacement of the object from t equals 0 to t equals 1. Now we have to find the expression of acceleration. Acceleration is just v dash t. So part B, acceleration is v dash t. So we have to differentiate v with respect to t. So yeah, it'll be minus 3t square, yeah, plus 7t minus 2. So that's the answer to part B. Now part C, greatest speed be reached by the object before it comes to rest. So for the greatest speed means it's the maxima, right? So for the condition of greatest speed, we have to equate v dash t to 0. Right? That's the condition of maxima or minima. Then check whether v dash and the solution of v dash t equals 0 is less than 0. And yeah, if these two conditions are satisfied, we know that the highest speed will be reached. So yeah, just write it down. When v dash t equals 0. You know, actually also solve it with the sign scheme method. So let's try it. So this is the maxima or minima condition. So yeah, minus 3t squared plus 7t minus 2. This is v dash t, right? We'll equate it to 0. So yeah, we can factorize this thing. 7t plus 2 equals 0. So yeah, 3t would be t minus 2. If I take minus 1 common, t minus 2. T minus 2, 3t minus 1 equals 0. So yeah, we'll have two solutions. T minus 2 equals 0, 3t minus 1 equals 0. It gives you t equals 2 seconds and t equals 1 by 3 seconds. Right? Okay, now we have to check. We can use the sign scheme method to check whether which one is the maximum and which one is the minimum. So our domain is between 0 to 4 seconds. Yeah. And yeah, here you'll have 1/3 seconds, and let's say here is 2 seconds. So well, how do I draw the sign scheme of fx? Sign scheme of v dash t. So I have to put a value between less than 1 by 3 to v dash t, right? So I can try 0. So v dash t is minus 3t square plus 7t minus 2. If you put t as 0, you'll see that the v dash t is negative. So this entire interval would be negative. Right? Between minus 3 and 2, we have to choose one value. Let's say let's put in 1. So minus 3 plus 7 minus 2, which is 2. So this entire interval would be positive. Okay, and between 2 to 3 we can put in 3. In 2 to 4 we can put 3, right? So minus 3 times 3 square plus 7 times 3 minus 2. So 9 times is minus 27 plus 21 minus 2. So it's minus 6 minus 2, which is minus 8. So this entire interval would be negative again. Now how would I know whether 1 by 3 and 2 are maxima or minima? So you see the curve is decreasing till 1 by 3, then it's increasing to 2. Okay, then again it's decreasing, right? So obviously this is the point of minima and this will be the point of maxima. Okay, so at t equals 2, your velocity will be maximum. Velocity is maximum. Now we have to find the maximum velocity. We have to find v of 2. V of 2 would be how much? Yeah, we have to plug in 2 in the velocity equation, which will be minus of 2 cube plus 7 by 2, 2 squared minus 2 times 2 plus 6. So it's minus 8 plus 14 minus 4 plus 6. So finally v of 2 becomes 8 meter per second. This is the maximum velocity. Right? And this will be the answer to part C. Now moving on to part D. We have to find the greatest speed reached by the object for 0 to t to 4. Right. So in this so in this curve, what's the greatest speed? So greatest speed means like its speed would be mod of vt. Right. So we have to find at which value we have the greatest magnitude of velocity. Right. So one you have already found out that is this value. Right. This is 8 meters. But we can also check the boundary condition, which is here. Right. And this is occurring at t equals 4 seconds. So let's try to find out the velocity at 4 seconds, see if it's if the magnitude there is greater than 8 or less than 8. So v of 4 would be minus 4 cube plus 7 by 2 4 squared minus 2 times 4 plus 6. So it'll be minus 64 plus 56 minus 8 plus 6, which is minus 10 meter per second. Okay, so we see that like at t equals 4, the velocity has a greater magnitude at as compared to 2, right? So therefore, the greatest speed reached by the object is 10 meter per second at t equals 4 seconds. And that will be the answer to part D. Now for part E, we have to write an expression that represents distance traveled by the object while the speed is increasing. So yeah, now we can actually get the intervals where the speed is increasing from the graph itself. Okay, so here this is approximately like t equals 1 by 3 seconds. This is t equals 2 seconds. And this point is t equals k, right? Because it says in the equation, I mean in the question, that the object will first come to rest at t equals 4 seconds. And this is approximately t equals 4 seconds, right? So here the curve is decreasing from 0 to 1 by 3. You see here, as the value of x is increasing, the y is decreasing. But from 1 by 3 to 2, the curve is increasing, right? So we have first found this interval, like between 2 and 1 by 3, the speed is increasing, right? Another is like after 2, what happens is the object slows down, becomes gets the speed 0, right, at t equals k seconds. After 0, it starts going in the opposite direction with negative velocity, right? So the speed is increasing here, and speed will increase from k to t equals 4. So these are the two intervals where speed is increasing. Now we have to find the distance traveled by the object when the speed is increasing. So distance, right? So E. So yeah, your distance would be traveled when speed is increasing. This will be equal to the integral 1 by 3 to vt dt. This distance will be positive, right? The displacement is positive, so I can directly take it. So for the one k to 4, the area will come out to be as negative. So I'll do mod vt dt. So yeah, this will be the expression of the integral. So with this, we are done with this paper, and I'll soon be back with the solution to another paper. Thank you so much.